Hi guys, welcome back to Lewis Custom Knives. This is part 6 of building our heat treatment oven, and today we will be talking about the schematics of the control box as well as the rest of the oven. Okay, let's get straight to it then. If you are not comfortable in any way by dealing with electrics and electronics, have a qualified electrician do this for you. If you screw up, damage to property, serious injury, or death can occur. So, once again, sorry for the scary intro, but it has to be there. So what I'll be trying to do is I'll be trying to explain everything in your everyday speak, if you like, and I'll try to demystify everything, because most of the people who will or may be watching this video are probably not electrical engineers, myself included. I'm not one, and it is really not that difficult. One skill you will be needing is you will be needing some basic electronics knowledge and how to read a very, very basic schematic. Okay, but so I have an empty sheet of paper over here, and I will be talking through it as I'm doing everything, so ideally make things as simple as possible. At least that is the goal. Okay, so let's get started then. So of course, everything's going to be, in the very beginning, everything is connected to our power socket. For the purposes of this schematic, we will ignore the ground terminal. However, trust me, it will be connected. Okay, but for the purpose of this, we are ignoring the ground at all, completely. So, you've got your two prongs coming in. One of them, of course, is live, the other one is neutral, and there's 240 volts on AC current on the line. Okay, now in order to make sure that my schematics will be as clutter-free as possible, I will not be drawing every wire that is connected to the neutral. I will just be indicating, and you'll see what I mean, that it is connected to the neutral. So the first thing that's a live wire is going to hit once it comes into our control box is going to be our circuit breaker. Okay, because that's important. I'm trying to make sure that is the first thing there. So if the circuit breaker trips, everything shuts down. Okay, no questions, no nothing. And then you can investigate in relative safety, of course, after unplugging the oven first. Afterwards, what is going to be there is our master switch. Okay, that will ensure that we can shut our oven off safely. Okay, then our 240 volt AC bus is what we would like to call it, will be split, and the first branch of it is gonna go down to our magic black box, which is the PID controller. Okay, the other half is, of course, connected to the neutral. Okay, so now our PID has got power. So we are extending our 240 volt bus further, and the next split is going to encounter is going to be a 12 volt power supply. Okay, and that is 12 volts DC, and that is the plus terminal, and that's the minus terminal. Okay, so, and of course the other end of it is connected to the neutral. So the 12 volt terminals, they are connected to various things. They control quite a few bits and pieces around the whole oven. The first thing it will be controlling, rather obviously, it will be going into the PID, to the output terminals. The way my PID works is that it acts like a big relay, which means that it can switch power on and off. Okay, it can't supply its own power to the output terminals, but it can switch some external power you're giving to it, as long as it's not very high and doesn't burn out the PID. Read your manual that comes with your PID and see how your particular one is wired and how does it operate. Okay, so that's where the first half of our 12 volt bus goes. Okay, now once that 12 volts comes out of the PID, where it's going to go is it's going to go into another switch. That switch is our heating element isolator. Okay, that red missile style toggle switch I showed you in two videos ago. Okay, that will allow us to effectively kill the elements without turning the whole oven off. Okay, so after it goes to the switch, it goes into another device, which is our solid state relay. Okay, and out of this, when it comes out of the solid state relay, it simply goes back into the minus terminal of the transformer, 12 volt line. Okay, another thing that is going to be running on the 12 volts that we are doing is the two fans that we've got, and we will indicate those with the motor sign. Okay, they will be of course connected in parallel. And there we go, they come back into the minus, and this way we'll ensure, as long as we click our oven on, the transformer will be energized and the current will be able to travel to the motors and to the ventilators or fans, and they will be able to provide cooling air. So as long as the oven is on, the cooling air is going to be flowing, which is always a nice thing. Okay, and then everything comes back again. And the third thing that our 12 volt DC power supply will be doing, it will be going through another switch, which is our door interlock. Okay, so this is our failsafe. If we open the door, the heating elements get switched off automatically, and afterwards it's going to be going into the relay coils. Okay, let me just put this symbol down there. Relay, and then it comes back out and gets connected itself back to the minus terminal. So this is what our 12 volt DC bus will be doing, but we are not finished yet with a 240 volt AC. So that, after being split to go to the transformer and do all the other interesting things, will be going further on. Okay, and going into our relay. Okay, now our relay will be switching on and off both the live and the neutral poles of our wiring. Okay, but for the clarity's sake and for the lack of clutter, I will only be showing the live. So it goes into the relay, where if there's power, then this current will be allowed to through. It comes out of the relay, and afterwards what I'll be making sure that it goes into the solid state relay. However, in the meantime, what it does another split where it goes into a warning light. Okay, and that warning light is afterwards connected to the neutral. This warning light will give me an indication that if this relay is on, the elements have a chance of being live. Okay, which means that there is power coming in this direction towards the SSR, the solid state relay. In other words, if I open the door and this light does not go out, I have a problem. Because this light is designed to go out if there's no power, and as such if the elements can't come on, because we do have this switch over here that in theory should be switching off the relay. So that will be our first indication for two reasons. A, our wiring isn't correct, or B, the relay has failed. Okay, these switching contactors, like the mechanical relay, they can fail. The SSR can fail as well, by the way, but you know, if it gives us an indication that something's wrong, okay, before we hurt ourselves. Now, what it does when the 240 bus comes out of the SSR, it goes into the heating elements. Okay, there we go, there they are, the big heating elements that we have in our oven. And the second one as well. And that gets connected to the neutral. Now, what I also want to do is I'll add another warning light right here. Because, well, I have two and I might as well use them. And this warning light, afterwards of course being connected to the neutral, and that warning light, what that will do is it will give me an indication. Basically it will flash on and off. Okay, it will be on constantly while the oven is up to temperature, and once it is up to temperature it will start flashing. If that light is on, that means that the heating elements are on. Okay, they are doing their work. If that light is off, that means that the circuit is dead as far as after the solid state relay. Okay, so that particular one isn't necessary, and if I find that my control box is really cluttered up with a lot of various other pieces and wiring and everything else, I can exclude this. This is not necessary though. But but it would be nice to have it though. Okay, and of course one last thing we did not do is our thermocouple, which is of course sitting inside of our oven. The TC, which has got two wires which are connected directly with no interference with anything else, because we want the accuracy. They are connected directly to the PID. And that is pretty much it really. Okay, now obviously of course there is another wire which is the neutral, which we didn't show at all. There's also the ground wires, which are extremely important. As well as, of course, our relay, like I said, it switches on and off both the neutral and the live wires at the same time, just to make sure that if, in case there's a cock-up somewhere in here, and if we swapped our live and neutral wires, both of them get switched off. Okay, so there's absolutely no way for the heating elements to be live when the door is open. So that should work perfectly fine. It's a very simple schematic as far as they go. However, you are, as always, expected and more than welcome to do your own research. If you do find something that is not correct or wrong with this particular schematic, or how it can be improved, please do post in the comments, okay? I do appreciate things like that. However, this is what I'll be going with at the moment. But this is not a guideline or an instruction of any description to do it for yourself. I do advise that you seek professional electrician's help if you've got any questions, and well, don't take advice of a random guy on the internet. But this is what I'll be going with, and unless if anything does screw up or explode, I will let you know, and we will be updating this. Okay, so this may or may not work. So this is pretty much it for this video. I'll be trying to keep them a bit shorter now, and as always, thank you very much for watching. In the next part we will start laying out the components in the actual control box and start assembling it little by little. But until that time, thank you very much for watching and have a lovely day. Take care.